Okay, so welcome everybody. Thank you, for coming in this large number. So first of all, I want to apologize. The idea was to do this meeting at the new building of the New Maint, the second housing co-op of Amsterdam after the Warren. So the New Maint itself was very excited about this meeting. They have a very nice cafe downstairs, but there is space only for about 40, 35 people. And we did not expect such a response. So we were a bit overwhelmed. So we organized for you the ivory tower of the University of Amsterdam with the view on the city. But please go to the New Maint, drink a coffee there, enjoy the building. It's open and it's a very nice building. And it will come back in the presentation. So my name is Federico Savini, and I'm associate professor in environmental planning here at the University of Amsterdam. And I will introduce the meeting of today. But first of all, I want to introduce the team of this research, because we did these things all together. There is Mira Koop from the Potsdam Institute of Climate Impact Research. Here, she will join in. We have Cody Oxtenbach, colleague, urban geographer here at the University of Amsterdam. Leshem Cohen, which works both at the University of Amsterdam and at the University of Leiden in the Department of Environmental Sciences. Peter Beryl, also at Leiden, Department of Environmental Sciences. And Stefano Merciai, working also at Leiden, Department of Environmental Science. Now, as you understand from these titles, thank you for clapping, by the way. It was not expected. As you understand from these titles, the reason why we are very proud to present this today is that it was a truly interdisciplinary research project. So we had a planner, a geographer, we had a mobility expert, an industrial ecologist, we had large life cycle assessment, material stock analysis experts, and other industrial ecologists. It was a very, very broad spectrum of researchers and disciplines, and we came together a bit by chance, I would say. Our team grew up quite organically. We started small, then we get new people in, and this whole research was actually not done with any particular research funding. So it is, in fact, a project from the grassroots of the academic world, I would say. Let's call it this way. And what did we do? So when we think about housing, we are thinking about two problems at the same time. On the one hand, housing is an essential need, and we know these days that there is what we call a housing crisis, or a cost of living crisis. People don't find houses at affordable prices, right? On the other hand, when we think about housing, we think about basically big material stocks like bricks, concrete, steel, cement, wood, which are obviously digged from somewhere. So it's a product that is produced every day by literally excavating and extracting material from the earth, which makes it clear that when we need to solve the first problem, we need to consider also the second. You know, these days there are big political parties claiming to want to build 10 new cities in Holland in order to solve the housing crisis. You can imagine that we as scholars, we are like, yeah, I'm not sure where, how, but also whether that's really sustainable, no? To solve the first problem by increasing supply. And that's why we wanted to combine these two perspectives, the social perspective and the environmental perspective. And to do that, we basically took inspiration from the post-growth critique of the economy and society. And to represent the post-growth critique, you can think about a very famous donut model of Kate Raworth. You see an example here. The idea there is that there is an essential need that needs to be met, which is housing in this case, and we need to increase access to housing, but we also need to downscale the environmental footprint of housing as a whole, which means reduce the environmental footprint of housing, starting from not building what anymore, that is what is unnecessary. So we asked ourselves the question, what is indeed a post-growth approach to housing? How can we solve the social problem of housing accessibility within environmental limits? And to answer that question, obviously, we wanted to look at the housing situation in the Netherlands at the moment. And we did that in two ways. First, we studied where is housing, where are housing resources allocated. So who has access to housing and how much environmental resources these people use and consume in their everyday life. Okay, so this was the first question. We will explain more later. And at the same time, we also said, okay, if there are people in the country that already have a new way to live that is ecologically sustainable and socially just, what is their environmental impact? Is that really ecologically sustainable and just, or is not? So that was the two questions we had together, and we developed a whole model and to quantify also, okay, this aspect. Just to give a clarification, when we talk about housing, we're not talking about in terms of environmental terms, we're not talking about the use only of housing. So the electricity, the heating system. We're talking about housing as a product which has a long value chain. So we include what we call embodied carbon, so all the carbon that goes into the materials to build a house. But we also include the uses of other infrastructures which are related to housing, like mobility. Just to give you an example, if you live in the suburb and there are no jobs there, you're forced, or no public transportation, you're forced to take a car. That's the fault of the fact that you're living there, that you also need to take a car, to put it simply. So we included also mobility pattern. Okay, so these were our questions, and today we're going to present you the results of this research. And we'll try to do it in a simple way in order to allow for discussion afterwards. So we're going to have a presentation with few people coming here, and then after this we'll have a Q&A, and at the end, before the drinks, we will ask you to actually input also further research by joining a Mentimeter which we prepared for you, but I'm not going to say anything else at this stage. I would like to Cody?
Yes, I will just walk you through the basics of this research project, just to make sure that you won't get lost. After me, you will get an industrial ecology explanation. There I also get lost at some point. So basically, Federico already explained that we're interested in these planetary boundaries, carbon emissions, both use value as well as embodied emissions and indirectly related emissions. But we're also we're also interested in the social foundation, and that brings us to the question of social inequality. We're interested in seeing to what extent different populations living in the Netherlands live within planetary boundaries or beyond planetary boundaries, and to what extent, how much do they live beyond these planetary boundaries, and how big are the inequalities in that regard. Studying inequality, one of the things you will typically look at is income. So we also look at income levels, so inequalities between the poorest people and the richest people, say the poorest 10% or the poorest half of the population versus the richest 10% or the richest 1% of the population, for example. But when you think about inequality in housing, it's also very important to think about the ownership of housing. Who owns the house that you live in? Is it yourself, in which case you're an owner-occupier, or do you rent your house? And if you rent, do you rent from a not-for-profit housing association, een woningcorporatie in Dutch, often at a discounted rental rate, or do you rent from a private landlord who on average charge higher rents? Of course, there's also other forms of housing and tenure structures available. Look at the housing co-ops that we'll also be discussing, but since these are quite limited in numbers in the Netherlands so far, our analyses focus on these three main ownership typologies. Home ownership, people living in the house that they also own, which is about 60% of the Dutch population. People renting from housing associations, which is about 28% of the population, and people renting from private landlords, which is about 13% of the population. So this is the basis. We want to understand inequalities by income and inequalities by housing tenure in carbon emissions, as Federico just explained. And to do that, we need a lot of data. And I'm here to talk about the data part of our project. To get access to these data, we draw on register data from the System of Social Statistical Data Sets from the Dutch Statistics Bureau, CBS, which basically means that we have data for the entire Dutch population. So if you are paying tax in the Netherlands, very good, you're in our data set. If you're registered at the municipality in the Netherlands, you're in our data set. Well, you name it, all these kind of registers, things that are collected at an institution, the tax office or the municipality, and so forth. These data are collected by CBS and are made available to researchers. Don't worry, it's fully anonymized, so we can't go looking individuals up in the data. But it does present an interesting and a very rich source of data. And these microdata on Dutch households, it means that we have almost the full Dutch household population available. There's about 8 million households in the Netherlands, and I think our data set, we had to exclude some cases with missing data, for example, and we're left with something like 7.5 million different households, which is of course a lot of data. And from these data sets we can look at energy use, for example, where we look at electricity consumption, where we look at gas usage. We can also see what kind of, do they have solar panels, for example, or do they have a heat pump, or do they use city heating, stadsverwarming? Those kind of variables are available. We also know stuff about characteristics of the housing unit people live in. What age was it, what time period was it built in? Was it a 19th century building or built just after the war? Or was it a newly built building? Is it a detached dwelling or a semi-detached dwelling, or is it an apartment somewhere in a bigger block? And where is this housing located? So is it in an urban location? Is it a suburban location? High density or low density? And we combine this with a range of household characteristics pertaining to the income of the people, but also the household size, the household composition. Are the children living there? How many adults are living in this house? So this is all the register data that we combined into one big data set, and we supplemented the data set with survey data on mobility. So for the mobility patterns, we couldn't rely on full population register data, because no one registers where you actually go to by public transport, or well, NS probably does, but we don't have those data, or if you drive. But we, drawing on the survey data, we can see how many cars people own, whether these are electric vehicles or combustion engines, how often do they take the car, or do they go by public transport or cycle or work or walk, sorry. How far the distances they travel, all these kind of things, and we combine them into one big data set. Just to give an example, so this is what I just explained on the left hand side, and combining all these different profiles, we have 7.5 million households more or less in our data set, but we combine them into 6,600 household profiles. You can consider them sort of ideal types based on their income, poor, rich, middle income, I'm simplifying, or whether they own or rent, the building type, so is this a detached or a row house or an apartment building, the building period, the density of the location of the dwelling, and the distance to city centers, schools, those kind of amenities. So we can have different examples. We can look for one typology in our data set is the top 1%, the richest 1%, living in an urban apartment building from the early 2000s. I can already give away that the top 1% isn't associated with the lowest carbon emissions. But we can also compare that with social housing tenants in suburban row houses, built in the 1960s, and I could list 6,598 more examples, but I'll leave it there. These are the technical backgrounds, and then I'll hand over to Mira, who did a lot of the analyses.
All right, so let's have a blank screen before we get into the detailed work. So when we look at these over 6,000 groups of households, what do we find? I will show this plot a couple of times. That's why I will first explain what do we see here. We see on the first hand how large is the carbon footprint per person of each of these 6,000 household groups. So this is our planetary boundary measure, right? How much does each of these groups emit through their housing? And then we have a bit more on the social foundation side, the question of on how much space does each of these groups live per person, so the floor area per capita. And as Cody just explained, we have all of these groups in many, many different categories, so we can differentiate, for instance, as we do here, by the income level. How much does each of these households earn? And the first thing that we learn when we look at this information is that when we draw how much emissions we would still have available so essentially when we look at the carbon budget that's still left for the housing sector, including all of these activities, mobility, building houses, and energy use. So if we draw a line here and say this is the fair share that people in the Netherlands could still emit using housing, then we see that most of our sample is beyond that, far beyond that. And so essentially is contributing to some form of carbon overshoot. Given, of course, their constraints, the conditions in which they find themselves with housing. So this is the first thing that we learn. Housing as it stands right now in the Netherlands is unsustainable. And if we don't change this will exceed ecological limits. But then the second thing that we can learn by looking at this graph is that, and I think this can make us a little bit hopeful, is that given a similar, let's say, service level, like how much space you have available for yourself, there can be very different carbon footprints of this housing practice. So if you have 50 square meters per person available to yourself, you could have a carbon footprint of 2 tons per capita or per year, or one of 10, which is a massive difference, right? So this led us to the question: okay, what explains all of this variability, right, that we see in the data set? How can we? What makes some household profiles having a very high carbon footprint versus others manage to live with less, let's say, emissions? And for that we offer 3 explanations. One of them is social status, one of them is the location, and one of them relates to the technology installed, and we will now explore this together. So looking at social status and specifically the income that households have, Cody already mentioned this briefly. We do can first of all learn the rich emit more than the poor. This might not be super surprising to many of you who have seen maybe these Oxfam plots of hourglass plots of the top 1% emit so much globally and the poorest only emit very, very little. But I think there's 2 interesting things that we can learn here from this analysis also for the Netherlands. First of all, even within a country that is relatively equal as the Netherlands, the top 1% emit much more, or are responsible for much more emissions than the 99% below them, right, in terms of income. So these top 1% earners, they have almost like twice the carbon footprint of housing than the bottom like 60% earners. And the second interesting thing that we see from this graph is that most of this income inequality that we see comes from the car use. So it's actually related to mobility practices. And yeah, here I think we have one explanation that might also seem intuitive for you at first, and that is, well, of course, richer people tend to live more suburban, so don't they have like longer distances to amenities, and also thereby need to simply like drive further than many poorer households who might live in like social housing apartment blocks in very dense locations where they have a supermarket right around the corner. Yes, to some extent. But so on the one hand, we do see poorer households tend to live more urban than, let's say, the richer households, which tend to live a little bit more suburban. But at the same time, we can also see from this graph that even within the same like population density level, so urbanity level, even those that are living in the city center, let's say, for those, the rich people are driving much more than poorer people. So they are driving even more than rural, like the poorest rural households, right? That's it's quite a difference. So we know, yes, there is some effect of location. There is also an effect of income on mobility use. Yeah. So what we can summarize from this first exploration is, while we know that most of the Dutch population kind of overshoots the emission ceiling, some do so more than others, and these some tend to be richer households because they drive more. Now, as I said, this is mainly related to mobility use, but we do also see differences in building energy use. That's this part here, like heating, electricity use, etc. And we do see them, especially if we look at emissions by housing tenure. So who's owning versus who's renting homes. And there we see that especially, and this was a surprise to us in the beginning, because we know that homeowners tend to live more in like large single-family buildings, occupying substantial amount of space. You can imagine maybe your grandparents or so living alone in their big homes, which they bought sometime throughout their life. Yeah, despite them living this a bit more like splendid lifestyle, we here see that they have lower building emissions. And to understand than renters, and to understand why that is so, we need to look at the technology that's being installed in these homes, and we also need to look at power and incentive mechanisms that stand behind this technology. So we see here, this is showing how many households have solar panels installed, the percentage of households within that group have solar panels installed and have heat pumps installed. And we do see that homeowners and rich households have considerably more access to clean technology, if we want to call them like that, so to solar panels, to heat pumps, than renters and poorer households. So buildings of homeowners are about twice as likely to be equipped with solar panels, and buildings of rich households have twice as much heat pumps as the poorest. or even a bit more than twice as much. And our hypothesis here is that this we can't prove this, but our hypothesis is that this is essentially due to the fact that renters have less power, like legal power also but also maybe partially financial power to install these carbon saving technologies themselves. And landlords, on the other hand, don't have a really big incentive to do so because they usually don't pay the energy bills. So yeah, this gives us some, so essentially, I mean, if you want to imagine it, that might result, we think that this is not only giving us some explanation for this aspect of homeowners versus renters, but this can also explain why we didn't see so much inequality in terms of building energy use emissions by income, because richer households, although they might live a little bit more comfortably, they might still have a very warm home, they can afford to do so by the technology installed. They might have a heat pump, they might have a properly insulated home, versus poorer households who might still freeze despite having a large carbon footprint due to the gas use in their poorly insulated home. Right. So now that we have understood these the inequalities that underlie this carbon overshoot that we saw in the beginning, and we started to get a first understanding of conditions that may enable meeting social flaws and stay within planetary boundaries, that is living in urban neighborhoods, also living in retrofitted buildings that have new clean technology installed. We want to see which groups already manage to stay within planetary boundaries given the conditions that they have. And for this, we can look here to the left. These few dots here. These few dots just make 0.04% of the Dutch population. So it's a special group. But it could potentially give us some example. It's households that live in urban row houses constructed, recently constructed after 2000. They have exceptionally many heat pumps installed and tend to have less cars. They also tend to be like larger households, so like with more members, more like family-sized households, which also used to tend to have a kid, a child. And thereby tend to live also on less floor area per capita. So there's a bit of this question, like, is this really comfortable? Is this enough? Because what we also know is that all of them belong to the poorer 30% of the Dutch population. And this essentially triggers the question, this is a very specific demographic and a very specific building stock, and therefore we wanted to understand what is out there beyond this, what we can see here from the statistical analysis, which other housing concepts are there that where people are living comfortably within ecological limits. And for this, I now hand back.
Thank you, Mira. So basically, we wanted to see whether it's possible to live in that particular corner of that image, and I hope you have it fresh in mind, but in a way that allows also, comfort and a particular degree, in fact, of space and high quality environment. And to do that, obviously, we needed to look into the future, but the future is already existing, I would say. We looked at few examples of housing estates in the Netherlands that claim, or at least try to do that, right? And to do that, we built on the literature, of course, on post-growth, degrowth forms of housing, and looking at also the country of the Netherlands where we could find them. And we started with 2 cases, and we are now, later we will say, we're extending this analysis to other 2 cases. The first case we visited, some of you might know it, is the Ecodorp Boekel. This is in Boekel. Is basically a relatively rural for the Netherlands area near Eindhoven, and it's a project. I will not tell you all the details, but it's a very innovative project for a few reasons. First of all, it claims to have very high sustainability targets, and it does so by all kind of structural measures. For example, not having cement in any way, and having a circular material for the infrastructure, from the pipes to the isolation. There are about 36 households living there in an area, as you can see, of relatively medium to low density. So we're not talking about high houses. They do have 28 cars, okay, and you have to also understand that. So we took this as an example of what we called a non-urban housing co-op, okay. It's not legally a co-op, but it works like a co-op, and this is a debate for later, but it's most about the legal aspect. This was, again, the suburban, non-urban co-op. Then we wanted to look at something that is closer to the dense area of a city. So we went to Nijmegen and visited the UN. You might know also this project. As you can see, it's a bit older than the Ecodorp Boekel. You see it from the fact that the plants are grown. And it's similar. It's about 26 households, 54 people, and with about 10 children. And it opened in 2015. Legally, this is a social housing, actually, that is rented to an association of renters, which are organized cooperatively. These projects are similar in terms of technologies. This, for example, because it's higher density, you can see the floors are higher, they, for example, have cement foundations, which we needed to take into consideration. But they do have much less cars. They have 8 cars than the other, and which is because they are closer to the center and closer to public transportations. The other 2 projects, I will tell them in a second, but first I would like to invite Leshem to tell you a bit how these 2 performed in our, let's say, model scenario.
So we used the same model to calculate the carbon footprint of Boekel and Iowan. And so yeah, it's the same figure as before, where the floor area is on the y-axis and the carbon footprint on the x-axis. In these figures specifically, the x marker represents Boekel, and the triangle marker represents Iowan, and this gray line is the carbon budget ceiling. So if we look closer, we can see that most of the households in Iowan and Boekel managed to stay within the carbon budget. We also see, in fact, that when compared to the national profiles, all households have a lower carbon footprint, manage to have a lower carbon footprint at the same floor area per capita. We also see that that they managed to have quite a low carbon footprint while still being in a suburban environment, and comparative to their other housing counterparts, they also managed to have a lower carbon footprint. We also observe that on the national level, the households, as we mentioned earlier, the households that manage to stay within the carbon budget are usually lower income households. But with Boekel, for example, you can see that even a higher income household manages to stay within the carbon budget. We also have this figure, which breaks down the carbon footprint by processes. And we can see specifically, so we focus on the third quintile, income quintile, and we compare it to the national business as usual, we call it, carbon footprint. And we can see EU1 particularly achieves a low carbon footprint, and this is mainly because of there was no car use involved. We didn't see any car use in EU1. So basically EU1 has a policy or a goal of reducing their car ownership. They have about, I think, 8 parking lots for, as mentioned, 26 households. and they're still trying to further reduce their car ownership. So in the household responses that we received, no one had owned a car or was sharing a vehicle. So this is why the carbon footprint is very low. But then if you look specifically at the building material and emission and energy emissions, Buckel and EO1 are quite comparative, and I would say that they're also quite exceptional. And yeah, so this was the carbon footprint analysis for EO1 and Buckel.
Yeah, so obviously the reason why we chose these two cases and other twos is that in our mind we had a few questions taken out from the literature. Is first, very important to understand how housing, when it's dense and compact, maybe with a lot of shared spaces, performs environmentally, but also how it's combined with location, right? And in mind, actually, the very first case we had to study from this was the Nieuwe Meent, the place where we should have been today, because this is, again, a step further in our prototypes. It is a high-density housing co-op with only one shared van, okay, so even lower amount of car use, and a very high amount of efficient use of space because of their living groups on the tower. However, if we look at the literature, there is also research that argues that maybe the classic high density, highly urban social housing model is more sustainable even than this housing co-ops system. So the next project, we are actually in the process now of doing this calculation. The next project we are looking at is the Kavel Z1 in Amsterdam North, about 260 units of social housing, 100%, very nearby public transportation. Why we chose this? Because obviously here the income factor is very important, location factor is very important, and density factor is very important. And you can consider this a bit the opposite type within the prototypes of post-grow housing, the opposite of, for example, the Ecodorp Buckel, which is further from the city, but more, lower density. So this is where we are at now, and we will, of course, inform you. I have all your email address with the research results of this section. And now, before concluding, I would just want to give you an open question, also maybe some food for thoughts, building on what you heard today. What is important for us to know is not only how these 4 cases of post-grow housing perform. We already have indications that are quite sustainable and relatively just in terms of accessibility. But what is also important is the question for us is what would happen if everybody in the country would live that way. Not only, we can also ask what would be the environmental cost of transitioning from now to that situation. These are major political questions, obviously, because not everybody can live that way. We already know that not everybody could live like Ecodorp Buckel, given the density of the whole country. But still, it's important to ask ourselves whether these are models that can be upscaled or replicated, okay? Because that's, after all, the problem. It's a collective problem. So this is, let's say, the question for the future. And if you have inputs on both these questions and other thoughts, at the end, after the Q&A, while we have drinks or just before, feel free to actually put input based on these questions through this Mentimeter. We will try to use this also in the way we analyze the second part of our research. Thank you very much for listening.